Hello everyone, my name is Atanas Marchev. I'm a model-driven engineer in Fire, and today I'm going to talk about the way to communicate complex logic with ease. Have you ever had to present complex logic in a way that it doesn't leave your clients scratching their heads? Nobody cares about the implementation, but we still have to prove that we have a working product, right? Domain experts know what their requirements are for the most part, but when they give the developer something like these rules for an instruction that can be attached to orders in a stock exchange. You can read it if you want to, but you don't need to. It's very confusing. We, as the developers, get confused and turn up code that is just as confusing. We have found that expressing complex logic in prose is unreadable. On the flip side of that, it's very hard to explain what code does to non-technical people. This is the second point I am making, and now I am picturing a room full of wizards fighting each other about the nature of the universe. Apart from that, analyzing code is difficult. We can't get a quick overview from it from a glance. We need to go through every line of the code to figure out the structure of it, what it does basically, what the procedure does. We have to analyze it to figure out what the paths that the code can take during execution are. And apart from that, we will need an entire toolkit to figure out how well it's tested, if it is at all, and what's missing from it. This ancient artifact is called the Nassi-Shneiderman Diagram, or NSD. It was designed as a way to communicate complex procedures in a well-defined top-down structure. It can be abstracted either into low-level code that programmers can follow to implement functions. It can be written with tasks and words that domain experts understand, or it can be a mix of both so that it can be understood equally by the two parties. The most basic building block of the NSD is called the process symbol, but I will call it an instruction because it's not the 1700s anymore. We can show loops, which can be either test before, as the one shown here, or test after with the clause below the body. We also have parallel processing blocks as well, unfortunately. We have the case processing block, which we can use for switch statements. This is the return symbol, which I added to the diagram because I needed it for my project. This proves how easily we can extend this diagram. And this is an example procedure that uses a lot of decisions, which we can use for if statements. So how does this dinosaur solve our problems? First off, we have a much better abstraction to viewing a procedure. Because of its simple and intuitive design, it can be presented both to non-technical people and to developers. This means we save time explaining ourselves to each other. Because of the way it is designed, the diagram will show us if our program is too large and has to be split up into smaller methods. That way we can keep the developers in check. And if it's hard to read, yeah, probably we have to change the code somehow. The top-down structure also allows us to view paths that the procedure can be executed in. We have a complete overview of the entire procedure that the program does. This allows us to get a quick understanding of what we are looking at, and in the future, it will help us with debugging or presenting our procedures to clients. If you remember this beautiful wall of text that I showed you a couple of minutes ago, this is what it looks like as an NSD. Immediately, we start recognizing some of the paths that the procedure can follow. And it would basically take me 10 minutes to understand what this diagram says, but it took me 4 hours to translate it from the pile of words back there. You can try it out if you want to. So I have prepared a short demo for you guys here. We are using kernel F as a base for the demo, but the diagram is language independent. I am going to show that later on. We use a library to build the structure of the diagrams. So all I had to do was connect it to MPS. So let's say that you have toiled countless hours on your code and you want to show it to the client so he can approve of it. He doesn't, as we said before, he doesn't care about the implementation details, but still he would like to see what you've wasted his money on. And we show him our diagram. With it, he can start understanding easier what the procedure does. And he says, yeah, we want to change it so that one of the numbers has to be above 0 in order to execute this addition. So we can change it immediately, and the diagram will reflect that. And if it's not above 0, it's going to return an error. We can also display multiple diagrams with it. I'm going to talk about a bit about how this works. All you need to know for now is that from our expressions, kernel F expressions, we build NSD objects, which later get picked up by a renderer and create the diagrams that you see here. So after some time with back and forth with your client, you've come up with a actually useful function. This is the final part of the diagram that I showed a bit earlier ago. You don't need to understand it. It's just here for an example. You can sit down with the client and go through every single expression or NSD object with him. He can point to it and tell you, for example, that this is wrong or this is right. And let's say that he says that this is wrong and he wants us to change it. He can point to the diagram and we can select it, and then we can edit whatever he doesn't like. I'm going to revert it back. Apart from that, we have a very important function with this diagram, and it allows us to do this. After the client has approved of the code and the function, we would like to test it to make sure that everything works properly, and you would like to have some proof of that. So kernel F, that's why we use kernel F. Kernel F is interpreted, and we can test it pretty much immediately, and we have coverage, which was one of the main reasons this project was started. So we test our function, and we can see the coverage immediately on the diagram, and we can prove to our client that everything is okay. And now, for me to prove to you guys that I didn't just paint the entire diagram green, I'm going to break our tests. So we have some missing coverage data. First off, I'm going to reset the data. I'm going to run the evaluation again, and we can see immediately and exactly where we are missing some tests, which can be very useful for larger functions in a bigger project. And it can also be useful for the client. Apart from that, we have the ability to analyze paths. I have extended the library that we are using a bit to create this path analyzer that we can go through every single path that the procedure can take. You can see yeah, it's pretty simple. So on to the presentation. While there was a lot of abuse towards my supervisor in the form of many stupid questions, I also had several challenges that I thought are interesting enough to show here. We had to figure out a way to store the NSD objects. We had to choose how to present our diagram. And at the end, I'm going to talk a bit about the code coverage and how I implemented it. So the NSD objects have to stay as much as the editor is open um, and get cleaned up after we close it. The idea is that even though the function nodes are identical in both editors, if I closed one of the editors, the other one's NS diagram should not get deleted. And also, if we edit something somewhere else, it shouldn't break the diagram wherever we are looking at it in the editors. This means that our NSD should be editor specific. My first idea was to create a static cache map that stored all of the NSD objects in one object for the entire project, but it quickly became big and unwieldy. I did some thinking and I stopped on cache class that was stored in the editor of the function they represented. Apart from that, I extended the library a bit further to store a string value that we were going to use to store the node ID, the string representation of the node ID for the specific node that we built the NSD object from. We use node ID so that we don't tie up nodes into our code. That way, the garbage collector can do its job better. And yeah, the next interesting challenge was how to present the diagram. We figured out, I came up with 3 ways to do that. First off, I could create custom editor cells for every symbol. That means me translating the entire library into an MPS language or just the editor cells and build them for every symbol. I could translate the tree structure of the diagram and the objects into swing layout with custom component classes. Or I could use the library's built-in renderer to draw images and just put them inside MPS the way the library output them. I prepared a list of pros and cons for each and every one of them. So for the editor cell, yes, uh, it is native to MPS, which means we would have seamless integration. It has highly modifiable layout managers, which turns out a giant plus. I'm going to show you why a bit later. It's easy to maintain because of compartmentalization. It's got the best maintainability since we don't have to deal with external libraries and whatnot. We just have one thing inside MPS. We could do in-place editing, which would improve the usability of the diagram even further. Instead of me clicking on the diagram and then the cursor would point to the place where I can edit the code with kernel F's editors, I could actually just edit the diagram by itself. But it would be very difficult for me since I'm not very experienced with MPS. It would take me longer than I had. And I would have to learn how to implement custom cells and custom cell layouts. I would need custom cells because there are, as you saw, some irregularly shaped cells within this diagram. I could use swing as a bit of a less difficult variation. It's got good integration with MPS. It still has built-in layout managers. By fine-grained interaction, I mean we could do a bit more than just putting images. But in the end, it all boils down to mouse clicking again, and I would still have to have a separate editor where I could actually edit the diagram's contents. The minuses of these are that it's kind of a half step between pure graphics and the editor cells. And yeah, medium difficulty of integration with the library just means it will be more difficult than actually using the library. The pure graphical representation was the easiest to implement. Uh, it's uh, it's simple. It's got one level of presentation. It's just the library that outputs images, and that's it. It's got by fast deployment, I mean that yeah, I would just have to figure out the expressions, how they would translate to NSD objects, and then the library would do the rest. It's very simple to maintain because it's basic Java. The minuses of these are that it has a very simple layout manager, and I have to do manually everything. By everything, I mean these three things: drawing, everything by hand, and everything with renderer from the Stone Age. Font and size management, I have to do manually and probably with a lot of checks, and you will see why a bit later. Interaction is very simple. I have mouse clicking that I have to calculate every single coordinate to figure out what I am clicking on, and it can be done much easier, much better, not much easier. And yeah, layouts you will see in a bit. In the end, we chose the pure graphics because I didn't have a lot of time doing this project. So if we look at this diagram from a previous version of my fork of the library, we start seeing several problems with it. In the first decision, we have some text drawn on top of a line, which looks ugly and is hard to read. After that, we start going a bit deeper, and we see that we probably can make the diagram smaller by removing some of the white spaces. This, however, might change how the text fits on its parent's object. So we need to make a top-down and a bottom-up decision for all of the nodes for our diagrams. This already exists in Swing and MPS, so we don't really need to reinvent the wheel. We just need to upgrade from our Stone Age rendering mechanism. Code coverage turned out surprisingly easily because the interpreter infrastructure supports coverage. All I basically had to do was cover some blocks in the library, which was basically the selling point of the entire project, and rightfully so, since it leads to a very colorful presentation. Point me to a boss who doesn't like seeing colorful images when you're explaining something complicated. Generally, extending the NSD plugin to other languages is fairly simple. In order to have coverage, one would need an interpreted language or the according tools, but we can do it to languages without coverage as well. In fact, we can do it to any language because we made it language independent. And to prove that, I extended the diagrams to base language. We have pretty much the same functionality we have with kernel instead of except the coverage. We can still select nodes, we can edit the code, and the diagram will eventually get updated immediately. So let's say we can do this. We can select nodes and we can do path analysis. Back to the presentation. So if it is decided to move forward with the project, some of the steps we could consider would be upgrading the presentation, of the diagrams to either Swing or MPS editor cells. And debugger integration for the diagram would improve and increase its independence even more. With a debugger integration, we can make the diagram even more functional by having the possibility to see variable values and the reason for decisions taken and the paths that these decisions led to immediately on the diagram. You can see. If you have any questions, you can leave them in the comments. Thank you for listening and looking at this. I have the links as well in the comments in the description of the video. And that's it. Thank you. You can contact me on this email for any questions of the project and fire.